Aqa Gcse Chemistry Higher Tier Paper 1 2021. Download the paper from the link below. Question 1. Fullerenes are molecules of carbon atoms. The first fullerene to be discovered was Buckminster fullerene C60. 1.1. What shape is a Buckminster fullerene molecule? The shape is spherical. Question 1.2. Give one use of a fullerene. Any one of these will do. 1. Drug delivery around the body. 2. For storage of hydrogen gas. This is because it's got a large surface area. For antioxidants, reduction of bacterial growth. Catalyst, again for large surface area. Cylindrical fullerenes are used for strengthening materials. Spherical fullerenes are used for lubricants. Question 1.3. Complete figure 2 to show a propanol molecule. Use a line to represent each single bond. So here is the structure of figure 2, and for propanol I'm going to put a carbon, hydrogen, 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 another carbon, hydrogen, 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 and that is what we call propanol. It's a ketone. It's a ketone where the R is a CH3 alkyl group, and that's what you see in there. Question 1.4. Determine the molecular formula for propanol. The molecular formula will be, we got CH3 here, and the next one is CO, and the last one is CH3. So because I've got 2 C's, 3 C's, so that'll be C3H6O. And you got CH3 here, and that's CH3. You got CO, that's CO. You got CH3. So if we count the number of C first, 1, 2, 3, C3, 6, 3 hydrogen here, 3 hydrogen, add them together, 6, and 1 oxygen atom. So the molecular formula is C3H6O. Question 1.5. Propanol is a liquid with a low boiling point. Why does propanol have a low boiling point? We need to select one of those answers below, and the straight obvious answer is because it's got a weak interactive force. Question 1.6. Figure 3 represents the structure of graphite. Explain why graphite is a good electrical conductor, soft and slippery. You should answer in terms of structure, right? Because this is 6 marks, so you need at least 6 points. 1. The bonds are covalent. So this bond between carbon and carbon is covalent. 2. Giant molecular structure. As you can see, it expands into a big structure here. 3 covalent bond per carbon atom. The yellow ones are carbon. So if you look at that carbon here, it's got 3 covalent bond to that one, 1, 1. So for every carbon, it has 3 covalent bond. 1, 2, 3. So the green lines are covalent bond. 4. So 1 electron per carbon atom is delocalized. Well, carbon is meant to have 4 bonds. So literally, if you're drawing a carbon atom, you'll be drawing 4 bonds for a carbon like that, and that's carbon in the middle. So that's normal carbon because carbon is in group 4. Now, the carbon we're dealing with here is only got 3 bonds, 1, 2, 3, and because this carbon now has 1 free electron to flow around, so that's the free electron. So each one of them is free and they can flow around, hence we call this free electron delocalized electrons. 5. These delocalized electrons can move through the structure, so they can go around there, down to the structure, and everywhere in the structure. 6. Carrying electrical charge. Well, electrons are negative, as you know, they're E minus, so because they're negative, they carry the negative round, hence they conduct electricity. 8. Layered structure of interlocking hexagonal ring. The structures here are hexagonal because they got 6-sided shape, and here they are again, and then they form a layer on top of another layer, and that's what number 9 comes in. They have weak intermolecular forces between layers. So this layer here, these are covalent bond here, and here are intermolecular forces. They're weaker bond, and so the layer can slide over each other because these bonds are weak. They can slide over each other. So graphite is soft and slippery. If that distance is d, the one layer, and then the distance to the next layer is going to be 2.5 d. Question 2. This question is about atomic structure and the periodic table. Gallium Ga is an element that has two isotopes. 2.1. Give the meaning of isotopes. You should answer in terms of subatomic particles. We have to mention protons and neutrons because protons and neutrons are the subatomic particles we're talking about here, not the electrons. This is referring to the nucleus. So isotopes are atoms with same number of protons but with different number of neutrons. The table here shows the mass numbers and percentage abundance of the isotopes of gallium. So one isotope, another isotope. Calculate the relative atomic mass of gallium. Give your answer to one decimal place. So the first thing to do is to multiply the relative atomic mass by 100, and that equals 69 times 60. So you just multiply those two together. Oh, by the way, this has to add up to 100 before you do that. And 71 times 40, and we add them together. And then we need to divide both sides by 100. So now we've divided both sides by 100. That 100 will cancel 100, and there will be 100 here, which is that. So now if we enter that into your calculator, you should get the relative atomic mass of gallium is 69.8 grams per mole to one decimal place. Question 2.3. Gallium is in group 3 of the modern periodic table. Give the numbers of electrons and neutrons in an atom of the isotope 6931. Okay, because we're dealing with atom here, which means that the top one here is atomic mass, and atomic mass is the nucleus of an atom, which is protons plus neutrons. So that's A. And the bottom here is always the atomic number, which is Z, which is number of protons. And the number of neutron is the mass number minus the number of protons. So the number of proton is 31, as you can see there, and the number of electron will be 31 because we're talking about atoms. In an atom, number of protons equals number of electrons. And now we can find the number of neutron. That will be 69 minus 31 because proton is 31 and the mass is 69, and that gives you 38. So neutron will be 38 and proton will be 31 and electrons will be 31. So the answer is looking for number of electrons, which is 31, and the number of neutrons, which is 38. 2.4. What is the most likely formula of a gallium ion? Right, because we say gallium is in group 3, we would expect it to lose 3 electrons, and so therefore the most expected ion will be plus 3 ion. So we're expecting it to be that one. Question 2.5. Gallium was discovered 6 years after Mendeleev published his periodic table. Give 2 reasons why the discovery of gallium helped Mendeleev's periodic table to become accepted. Gallium fitted in a gap Mendeleev had left. Gallium properties were predicted correctly by Mendeleev. Question 3. This question is about the extraction of metals. Element R is extracted from its oxide by reduction with hydrogen. The equation for the reaction is 3 hydrogen gas plus RO subscript 3 will give you R plus 3 water. Question 3.1. The sum of the relative formula masses MR of the reactant, this is the reactant here, is 150 grams per mole. Calculate the relative atomic mass of R. So we need to find R. Okay, so we know the total reactant. This is the reactant and that's the product. And the total reactant is 150 grams per mole. And so we got 3 hydrogen gas. That means 2 hydrogens in there times 3. That would be 3 times 2. And hydrogen mass, relative mass is, atomic mass is 1. Plus R, which what we're looking for, plus 3 oxygen. Oxygen is 16, so 16 times 3. And that equals 150. Now, this is 6. Plus 48 plus R, because that's 48 and that's R. I need to take away 6 from both sides and 48 from both sides. So we get R to be equal to 96 grams per mole. So because R equals 96 grams per mole, and we need to look for 96 grams, so we're looking for A to be 96 grams per mole. So we have to come to the big one, and the one closer is the molybdenum. Pronunciation might be mol, and you can say lib-du-num. So that's the best way to pronounce it. Quite difficult to pronounce. And the symbol for that is MO, as you can see here. Question 3.3. Carbon is used to extract tin from tin oxide. The equation for the reaction is given here. And calculate the percentage atom economy for extracting tin in this equation. Relative atomic masses have been provided. So the atom economy in this case will be, we want to work out the total mass of the reactant here, right? And then we want to work out obviously we do mass of tin, the mass of tin, and the atom economy will be the mass of the product that we need the tin, over the total reactant times 100, because what we're looking for is not carbon dioxide, we're looking for tin. So we need to work out the relative atomic mass of the reactant and the relative atomic mass of the product that we need, useful product we call that. And so the relative atomic mass of the reactant is 19 for tin, 32 for 2 oxygen, each is 16, and 12 for carbon. That add up to 163 grams per mole. And tin is given, which is 119 grams per mole. So the total mass, which is 163, and the atom economy will be 119, that's the useful mass, over the total mass of the reactant, times 100. In fact, that mass should be the same as the product as well, provided no gas escape. So if you add this up, it will be the same as the reactant. So you could say divided by the total mass of the product, provided nothing escaped from the product. So that gives 73%. So the atom economy is 73%. That means 73% efficiency from this reaction. And the other 27% is lost to carbon dioxide. Question 3.4. Tungsten is a metal. Tungsten is extracted from tungsten oxide, WO3. All other solid products from the extraction method from the tungsten. Table 2 shows information about 3 possible methods to extract tungsten from tungsten oxide. Method 1. A reactant is carbon. Relative cost of reactant is given, which is low. And product is tungsten solid, carbon dioxide gas, and tungsten carbide, which is also solid. And method number 2 is hydrogen, the reactant, so higher cost of the reactant. Tungsten solid and water vapor are the products. And method number 3 is iron and low cost in this case, and the products are tungsten solid, iron oxide solid. Evaluate the 3 possible methods for extracting tungsten from tungsten oxide. Okay, so this is 4 marks. We're looking for 4 points. Any of these points will do. Carbon and iron are the cheapest reactants. Hydrogen gas is most expensive reactant. Separating solid product is expensive. Separating solid product is time consuming. In method 1, some tungsten is lost as tungsten carbide. In method 1, the carbon dioxide produced will escape. In method 2, the water vapor produced will escape. In method 2, no separation of solid is needed. But in method 3, tungsten needed to be separated from iron oxide. Question 4. This question is about group 1 element. Give 2 observations you could make when a small piece of potassium is added to water. Okay, this is a 2-mark question. So potassium will float in water. It moves about. It effervescence. That means gas is giving off a color flame of lilac, maybe seen. So any of these will give you 2 marks. Any 2 from here. So question 2.4. Complete the equation for the reaction of potassium with water. You should balance the equation. Okay, so balancing this equation, I'm expecting potassium with water to get a potassium hydroxide plus hydrogen gas given off. So that's a gas. And so this is aqueous, and I'm expecting that to be solid, and water is liquid. Okay, so we need to balance this equation, and best way to start off with is I have got 2 hydrogen here, 2 there. Well, that's 3. So I may need to put 2 there, because then I've got 4 hydrogens, so I can put 2 there to make 4. And now I've got 2 oxygen here, 2 times that means I've got 2 oxygen here, so that's good. So there's 2 oxygen here, 2 times that, and 2 times that oxygen. 2 potassium, 2 times K, that's 2K. I need 2 here, so I need to put 2 there. And now I think it's all balanced. 2 hydrogen plus 2 hydrogen making 4, so that's 4 hydrogen, and 2 potassium and 2 oxygen here, 2 oxygen here. Now for conservation of mass, the total mass of reactant must equal to the total mass of product. That's conservation of mass, so that's good, that's balanced. Question 4.3. Explain why the reactivity of elements changes going down group 1. So 1, reactivity increases going down a group. 2, because the outer electron is further from the nucleus, here's the electron here, outer electron, so that there is less attraction between the nucleus and the outer electron. So the further you go down the group, the further the electron is away from the nucleus, the outer electron. And so the atom can lose an electron more easily. And that electron can be lost easily because it requires less energy to kick the electron out. Question 4.4. Draw a dot and cross diagram to show what happens when atoms of sodium and oxygen react to produce sodium oxide. So in order to write this down, I need to know what group sodium belongs to. So sodium is in group 1, so that means it will form +1. Oxygen is in group 6. It can't lose 6 electrons. It has to gain 2, so that will be 2 minus. In order to write this compound for these ions, I need to move the number here, 1, and bring it down, and bring that 2 down here in the opposite direction. And so the formula for this one would be 2 sodium and 1 oxygen. So that's the formula that I need to be able to draw my dot and cross diagram. So now that I know I need 2 sodium, 1 oxygen, so that's my sodium, and that's my oxygen, and that's my sodium. You can see sodium has got 11 proton, oxygen has got 8, and sodium has got 11 there. So I know sodium is in period 3, so that means it's got 3 shells, and the outer shell is only got 1 electron, and sodium is 281. So naturally you write 281, and being an atom, it's got the same number of proton as electron. So proton is 11 in the nucleus, and neutron is 12 in the nucleus. If you take away proton from that, you get a neutron, and it's got 11 electrons on the shells. Oxygen is got 8 proton, 8 electrons, and 8 neutrons and protons in the nucleus. And this is the electron configuration. For oxygen is going to be 2, and you got the 2 there, and then you got 6 on the outer shell, so 2, 6. And for sodium again is 2, 8, 1. You can see how many periods they have. It's got 2 periods, that means it's in the second period. It's got 2 shells. 1 shell, 2 shells. 1, 2, 3 shells. 1, 2, 3 shells. Number of electrons in that shell, 1, 8, and 2. So now we got this. And so what's going to happen is there's going to be transfer of electron. I'd rather lose 1 electron than to gain 7, because it's too expensive to gain 7. So that electron will go to oxygen there. Oxygen rather gain 2 than to lose 6 electrons. So it would want to gain. Again, same thing. It would lose that electron and give it to oxygen. So that's what we're going to have next. So what's happened to the charge here? I've gone from 0 here to sodium plus. So that's Na plus. So that's an increase in charge for sodium. And so sodium is what we call oxidation, because I've gone from 0 to +1. What about oxygen? I've gone from 0 to O to minus. So the charge here has decreased from 0 to -2, and decrease in charge is reduction. So that's a reduction because there's a decrease in charge here, or electron being added to that. So gain of electron or addition of electron is a reduction as well. So for oxygen, 2 things happen: decrease in charge and gain of electron. Question 4.6. Explain why sodium oxide has a higher melting point. Because 1. Sodium oxide is a giant structure. 2. Strong electrostatic force of attraction exists between the cations, which is the sodium plus, and the anion, which is the oxygen 2 minus. 3. Large amounts of energy are needed to break the strong electrostatic force of attraction. Question 5. This question is about salts. 5.1. Name the salts produced by the neutralization of hydrochloric acid with potassium hydroxide. This is hydrochloric acid and that's potassium hydroxide, forming potassium chloride and water. So the salt formed is potassium chloride. Question 5.2. Write an ionic equation for the neutralization of hydrochloric acid with potassium hydroxide. So we're looking for ionic equation. So that means that hydrochloric acid will be H plus and that will be Cl minus in solution, will be K plus OH minus in solution, and you're going to get potassium chloride as plus and Cl minus, and plus water, which is just H2O liquid. Now what we call ionic equation is non-repeating ions. So you can see on both sides there's a equal sign here, so that we cancel that one out. You can see that's repeating, so that's repeating there. So for the ionic equation is any ions that are not repeated here on both left and right. You can see that the H plus the OH minus forming water. So that's obviously aqueous and that's aqueous. So now the ionic equation is the H plus aqueous plus OH minus aqueous, giving you water liquid. How did I know that this is going to be plus and Cl minus? Well, Cl is in group 7, so it needs 1 electron, so it's going to get 1 electron from hydrogen. So that's why I know this is minus, and that would be plus because it's only 1 electron being transferred. Likewise, potassium is in group 1, so it's going to lose 1 electron, so it will become plus, and then it will give that electron to OH, so that will be OH minus. And likewise, potassium is group 1, chlorine is group 7, so it needs 1 electron. Potassium is giving 1 electron away, so you can see it perfectly matches, and that's how I know. Question 5.3. Soluble salt can be produced by reacting dilute hydrochloric acid with an insoluble solid. Copper carbonate, and copper oxide are insoluble solids. Which of these insoluble solids can be used to make a copper salt by reacting the solid with dilute hydrochloric acid? We need to select one from this list. Okay, so we can see that this is a reactivity reaction. The copper, say for instance, reacting with hydrochloric acid, this can happen because hydrogen is higher in the reactivity series than copper, which means copper cannot displace hydrogen, but hydrogen can displace copper. So it won't be copper. So copper won't be the right one. And next one along will be copper carbonate and copper oxide. So that will be copper carbonate, which is that one, and copper oxide, which is that. So this is what would happen. The copper carbonate, the copper will swap places with hydrogen here, and the copper too will swap places with hydrogen there. So you can see copper carbonate plus HCl will give copper chloride plus H2O plus CO2. This is carbonic acid. This will then dissociate into water and carbon dioxide. This is copper oxide plus hydrochloric acid. Again, that will give you copper chloride plus water. Question 5.4. A student makes crystals of magnesium sulfate. This is the method used. 1. Add sulfuric acid to the beaker. 2. Warm the sulfuric acid. 3. Add a spatula of magnesium oxide to the beaker. Stir the mixture. 5. Repeat step 3 and 4 until there is magnesium oxide remaining in the beaker. Step 6. Filter the mixture. Step 7. Evaporate the filtrate gently until crystals start to form. Step 8. Leave the solution to finish crystallizing. And now question 5.4. Give one reason for step 2, 5, and 6. So for step 2, you need to speed up the reaction by increasing the rate of reaction. So that's to increase the rate of reaction or to speed up the reaction. Step 5 is to make sure all the limiting reactant has reacted. So it's to make sure that all the sulfuric acid has reacted. And step 6 is to remove the excess magnesium oxide, which is the excess reactant. Question 5.5. How should the filtrate be evaporated gently in step 7? By using a water bath or by using an electric heater. Question 5.6. Iron chloride is produced by heating iron in chlorine gas. The equation for the reaction is shown here. Calculate the volume of chlorine needed to react with 14 grams of iron. You should calculate the number of moles of iron used, the number of moles of chlorine that react with 14 grams of iron, the volume of chlorine needed, relative atomic mass of iron is 56, and the volume of 1 mole of gas is 24 decimeter cube. So the way to start is to write down the mass and the relative molar mass or relative atomic mass. So for iron is relative atomic mass, which is 56 grams per mole, and the mass given for iron is 14. So I need to divide 14 divided by 56 to calculate the mole. So the mole is 0.25 mole. And the next thing I need to do is to look at the stoichiometric mole. So that's 2, 3, 2. All I need to do, the best thing to do here is to divide everything by 2. So if I divide that by 2, divide that by 2, divide that by 2. So the ratio I will get is 1 to 3 over 2. That's the ratio now. The new stoichiometric ratio will be 1. So that means that if the mole of iron is 0.25, but the ratio is 1 to 3 over 2 for chlorine, that meant that the mole for chlorine would be 0.25 times 3 over 2. So that will be equal to 0.375. So now we get 0.375. We do know that 1 mole equals to 24 decimeter cube. Therefore, if I times 1 mole by 0.375, I get 0.375 mole. I need to do the same here. And if I times 24 decimeter cube by 0.375, I get 9 decimeter cube. So therefore, the volume of chlorine gas equals 9 decimeter cube. Question 6. The question is about metals. 6.1. Which substance could be a metal? Substance C could be the metal because it has a high melting point and boiling point. It can conduct electricity in the solid state and liquid state. So that would be C. Question 6.2. Explain why alloys are harder than pure metals. Okay, so this is pure metal and that's alloy. Alloy is a mixture of metals. In an alloy, the atoms are of different sizes. So the layer of atoms in an alloy are distorted like that. This is a pure metal. So in an alloy, the layers slide over each other less easily compared to a pure metal. If you look at pure metal, the layers can slide over each other easily compared to an alloy, which is less likely. And because it's less likely, it's going to be harder than the pure metal. Question 6.3. A student wants to compare the reactivity of an unknown metal Q with that of zinc. Both metals are more reactive than silver. The student is provided with silver nitrate solution, metal Q powder, zinc powder, a thermometer, normal laboratory equipment. No other chemicals are available. Describe a method the student could use to compare the reactivity of metal Q with that of zinc. Your method should give valid results. Okay, so you want to measure any temperature changes when each metal is added to silver nitrate solution. Same concentration or volume of solution or same mass or mole of metal are used. 4. The greater the temperature changes, the more reactive. Question 7. This question is about chemical reactions and electricity. Question 7.1. Electrolysis and chemical cells both involve chemical reactions and electricity. Explain the difference between the process in electrolysis and in a chemical cell. So electrolysis uses electricity or current to produce a chemical reaction, and cells use a chemical reaction to produce electricity or current. 7.2. A teacher demonstrates the electrolysis of molten lead bromide. Bromine is produced at the positive electrode. Complete the half equation for the production of bromine. You should balance the half equation. So this is the equation given, but the clue here is that we are making bromine. So bromine liquid, and that will be Br2 because bromine is in group 7 and they form diatomic. And so that'll be Br2, which means I need to have 2 here. And if I have 2 there, I need to then balance the charge because I need to apply conservation of charge, and the charge is 2 times minus 1, which is minus 2, and on this side it is 0 here, and in order to balance the charge to give it a negative, I have to add 2 electrons, and so that would be 2 times minus 1, which is minus 2. So the charge is balanced on both sides. So that's conservation of charge. What about mass? Well, if you look at the mass, 2 bromine here and 2 bromine there. Okay, the conservation of mass is being applied. And this is the balanced equation. Question 7.3. 2 aqueous salt solutions are electrolyzed using inert electrode. Complete table 4 to show the product at each electrode. So in this situation, you're going to get the oxygen produced at the anode and the which is the positive electrode, and the cathode we get hydrogen being produced there, and iodine is also being produced at the anode, the positive, because for the iodine, which is iodide, making iodine plus 2 electron, because there's 2 iodine there, so that'll be times 2, so that's okay. Then you got hydrogen, also hydrogen gas being produced at the cathode. So for the hydrogen, you're going to get H plus, receiving 2 electrons, so plus 2A minus. So let's say 2 hydrogen, 1 H getting 2 electrons to then give H2 gas. And the oxygen also is always produced whenever you see from the nitrate, this is minus, and that's copper nitrate, and that's 2 plus, so nitrate will be obviously 2, and so you can see oxygen there, and that actually should be a clue that oxygen will be produced here. So now that's what's going to happen there. Question 7.4. Some of the copper produced did not stick to the negative electrode but fell to the bottom of the beaker. Suggest how the student could find the total mass of copper produced. 1. The student could filter the mixture. 2. Wash and dry the copper residue. 3. Weigh the copper collected. 4. Add to the increase in mass of the electrode. Question 7.5. How do the results in figure 5 support the conclusion that the total mass of copper produced is directly proportional to the time? So for a given current, a straight line through the origin, that means the coordinate, 0 coordinate here. Now let's look at the direct proportionality in the sense for the mass and time. So when we choose a current of 0.6 amps from the data, and time was 10 minutes and the mass produced was 0.212 grams, and at 20 minutes the mass produced was 0.24, so that has doubled. When this double, that doubles. That means they're directly proportional to each other. Question 7.6. How do the results in figure 5 support the conclusion that the total mass of copper produced is directly proportional to the current? Use data from figure 5 in your answer. For a given time, when the current doubles, the mass doubles. Here is the current, and this is the time. The time given is 20 minutes. When the current was 0.3, the mass is 0.12. And when the current now doubles to 0.6, the mass also doubled to 0.24. So when the current goes up, the mass also went up by the same proportion, which means that the current is directly proportional to mass. Question 7.7. Copper nitrate solution is blue. Suggest why the blue color of the copper nitrate solution fades during the electrolysis. The copper ions, which is copper 2+, which is blue, are discharged from the solution. So because they're gaining electrons and they become copper solid. So therefore the color blue disappeared. Question 7.8. Determine the number of atoms of copper produced when copper nitrate solution is electrolyzed for 20 minutes at a current of 0.6 amps. Give your answers to 3 significant figures. Use figure 5. Relative atomic mass. Copper equals 63.5 grams per mole. The Avogadro's constant equals 6.02 times 10 to the power 23 per mole. Okay, so at a current of 0.6 amps for 20 minutes, the mass obtained is 0.24 grams. From here, I know that mole is mass over relative atomic mass, in this case 0.24 over 63.5 for copper, so that's for copper, and that equals to 3.78 times 10 to the power minus 3 mole. Now 1 mole equals to 6.02 times 10 to the power 23 atoms. So now if I multiply that by 3.78 times 10 to the power minus 3, I get 3.78 times 10 to the power minus 3 mole, and I need to multiply that by the same amount times 3.78 times 10 to the power minus 3, and that will give the number of atoms, which is 2.28 times 10 to the power 21 atoms. Question 8. This question is about the reaction between hydrogen sulfide and oxygen gas. The equation for the reaction is shown here. What does H2O gas represent? H2O gas represents water vapor. Question 8.2. Calculate the volume of oxygen required to react with 50 centimeter cube of hydrogen sulfide. So looking at the equation, we can see that 2 mole hydrogen sulfide react with 3 mole of oxygen gas. And so all I need to do now is to, if I divide that by 2, I have to divide that by 2. So which means 1 mole of hydrogen sulfide will react with 3 over 2 mole of oxygen gas. And if that 1 mole is 50 centimeter cube, and to then multiply, because I'll multiply that by 50, if we times it by 50, because that's 1 mole, I need to times that by 50 as well. So that'll be 50 times. So if I times that by 50, I get 75 centimeter cube. So I'm expecting the 1 mole to be, which is equivalent to 50 centimeter cube, to be 75 centimeter cube for 3 over 2 mole of oxygen gas. So the answer is 75 centimeter cube. Question 8.3. Figure 6 shows part of the reaction profile for the reaction. The reaction is exothermic. Complete figure 6. You should complete the profile line, label the activation energy, label the overall energy change. So the energy profile for exothermic, this is it. This is the reactant and the energy path here, and the distance from the reactant to the top here is the activation energy, and the distance from the reactant to product is the overall energy change. So the overall energy change is minus delta H, and this reaction profile is exothermic. Question 8.4. Figure 7 shows the display formula equation for the reaction of hydrogen sulfide with oxygen. There's hydrogen sulfide with oxygen, and this is the display equation. And then it says, in the reaction, the energy released from a new bond is 1034 kilojoules per mole, greater than the energy needed to break existing bonds. Calculate the bond energy X for the SO bond. So what we do first is to calculate the bond breaking, because we need to break that, and we need to break that, and we need to break that. Now once you break those, we then rearrange it to make a new bond, and then make a new bond. Bond breaking is always endothermic, and that means the value for endothermic is always positive, and bond making is always exothermic, and the value for exothermic is always negative. And the overall bond that was gained is negative, because it says here it's minus 1034. And that bond is negative because it says energy release, and if energy is released, it's exothermic. All right, so we are calculating the bond breaking by that one, so it's going to be 2 times SH, because I've got 1, 2, so I've got 1, 2, then times 2. That'll be 2 times 2, that's 4. So that's 4 times 364, and that is the value. And for the oxygen gas, I've got 3 there. I just multiply it by 3, so that'll be 498 times 3 for oxygen. And when I add them together, I get that it's positive because we're breaking those bonds. When you're breaking, it's always endothermic, which is positive. Now, this one is, after breaking those bonds, we're making a new bond. So these ones, we're putting them together, so that's exothermic, that'll be negative. So this one have got 1, 2, and then times 2, that's 4. So 2 times 2 is 4. OHs, and that's 4 times 4, 6, 4, that one. And that will be minus because we're making a new bond. Likewise, these two will be minus as well. So we'll stick a minus here. So now what we now need to do is add up all the bonds together, and it will be equal to that one. So to add all the bonds together, so we're going to get plus 295x, and just pause there. So what we're going to do now is we're going to add these, which is sum of that plus that is this. We're going to add that to this one, and then that'll be equal to that. And so we're going to add that too. So the final value will be 2950, that's plus, then minus 1856 minus 4x equal to minus 1034. So I need to take 4x to the other side and bring 1034 to the left. So therefore we get plus 2950 plus 1034 minus 1856 equals 4x. I just move the 4x to the other side, and I move this to this side. And so now, once I've gotten to this point, and I need to add all this up, which after adding them up, I get 2128 equals 4x. So I need to divide both sides by 4, and then I get 532 kilojoules per mole. So x will be 532 kilojoules per mole. Question 9. This question is about acids, hydrogen chloride and ethanoic acid, both dissolve in water. All hydrogen chloride molecules ionize in water. Approximately 1% of ethanoic acid molecule ionizes in water. So question 9.1. A solution is made by dissolving 1 gram of hydrogen chloride in 1 decimeter cube of water. Which is the correct description of this solution? So this is a dilute solution of a strong acid. 9.2. Which solution would have the lowest pH? 1.0 mole per decimeter cube of hydrogen chloride solution. Question 9.3. A student investigated the concentration of a solution of sodium hydroxide by titration with a 0.048 mole per decimeter cube ethane dioic acid solution. This is the method used. 1. Measure 25 centimeter cube of the solution sodium hydroxide solution into a conical flask using a 25 centimeter cube pipette. 2. Add 2 drops of indicator to the sodium hydroxide solution. 3. Fill a burette with the 0.048 mole per decimeter cube of ethane dioic acid solution to the 0.00 centimeter cube mark. 4. Add the ethane dioic acid solution to the sodium hydroxide solution until the indicator changes color. 5. Read the burette to find the volume of the ethane dioic acid solution used. Suggest 2 improvements to the method that would increase the accuracy of the result. And this can be improved by 1. Swirl the solution properly so that it mixes during the titration. 2. White tile under the flask so you can see any change in color. 3. Add ethane dioic acid dropwise near the end point so that you don't overshoot. 5. Repeat and calculate mean. Ethane dioic acid is a solid at room temperature. Calculate the mass of ethane dioic acid needed to make 250 centimeter cube of a solution with concentration of 0.048 mole per decimeter cube. Relative molecular formula is 90. The formula for ethane dioic acid is H2C2O4 and the molar mass is 90 grams per mole. Mole is concentration times volume, and the volume given is 250 centimeter cube. If I divide that by 1000, it will become 0.25 decimeter cube, and the concentration is 0.048 mole per decimeter cube. So if I work out the mole, which will be concentration times volume, and that will be 0.012 mole. So to find the mass, I have to use N equals m over relative molecular mass. And I'm making m the subject, that will be equals to N times relative molecular mass, and m will become 0.012, which is the mole, times the molar mass, which is 90, and m equals 1.08 grams. And that's the mass we're looking for. Question 9.5. The student found that the 25 centimeter cube of the sodium hydroxide solution was neutralized by 15 centimeter cube of the 0.048 mole per decimeter cube of ethane dioic acid solution. The equation for the reaction is shown here, and calculate the concentration of sodium hydroxide solution in mole per decimeter cube. Okay, so I've got the stoichiometric mole. This is 1, so that's what stoichiometric mole of the acid, and this is 1 because here is 1. The concentration of the acid, the volume of the acid in decimeter cube, so I divide it by 1000. And for the base, I've got the stoichiometric mole of the base, which is 2, and the concentration of base we're looking for, and the volume of base is 25 divided by 1000 decimeter cube. Okay, so this is the formula I'm going to use. Because the ratio of the mole of the base is equal to the ratio of the mole of the acid at the end point. So I'm going to make CB the subject and multiply both sides by NB and divide both sides by VB. And so I get CB to be the subject here. Or I'm going to substitute these values in to calculate CB. So now CB equals to 0.048 times 0.015 times 2 divided by 0.025. And CB equals 0.0576 mole per decimeter cube. That's the concentration we're looking for.